So here's the basic idea of a boiler flush and what we're trying to accomplish. So on our purge cart, we've got a pump. This pump is picking up water from the reservoir. Picking up water from the reservoir, and we're forcing it out at about 15 psi at about 20 gallons per minute, which is approximately about 10 times the flow rate of what the boiler would normally operate at. So what we do is we come off, and you'll see in the next video of how to hook the cart up. We come off this pump, there's a connection here, and the hose goes up, and we're going to send water into the system on the supply side. Not always are we going to send it in on the supply side, but basically this is a simple example. So you're going to send the water in. What you're going to do is you're going to isolate the supply from the return so that your water is only going to go in one direction, out and through the zone valves. It's going to go out, it's going to go through the heating, and it's going to come back on each loop. The idea is that you hook it up and you send the water out from the reservoir through the system and then back through the filter and then back into that reservoir. Now you're going to run into some scenarios where this isn't quite possible to do it this simply. You're going to run into scenarios where there's no isolation. You're going to run into scenarios where you've got hose tips in funny locations. But what you have to do is you have to figure out, how can I isolate the supply from the return so that I can force that water to go through the zones and come back so that I'm flushing out the comfort loop portion of the system. You may find in some instances this may be a pump here, and there may be a mixing valve. So if there's a mixing valve, you've got a direct connection where the water is going to want to short circuit. You need to figure out a way to isolate this. Opening and closing the mixing valve isn't going to be enough to isolate. You also may have multiple zones, you may have multiple temperatures. You may have a high temperature loop and you may have a low temperature loop. Again, you need to figure out how you can isolate this. Quite often on the boiler, there'll be a boiler drain. That is the first place to look for sending water into the system. If you set it up here, you're going to send water through the boiler, out through the system, and it's going to want to come back to this hose bit, but only if there's isolation. If there is no isolation here, what's going to happen is you are going to short circuit. Water won't go this way, water will go this way and right out. So the idea is that you want to find a point where you can isolate the system. It doesn't hurt to flush the system out in reverse, but it's not quite as effective. Again, you're going to need to figure out ways to isolate mixing valves, and you're going to need to figure out ways to isolate your supply from the return. So you're going to have to really look at it closely, look at the direction in which they're flowing, and look at where you can isolate the system and how. Sometimes you may have to take out maybe a thermometer. Remove the thermometer, put a hose bib in, especially if it's upstream of the shut-off valve. Other things you can do on systems like this as well is there may be an air purger that's threaded in with a 1/2 by 1/8 nipple. You can take that out and put a hose bib in. So a lot of different ways to attack this, but that's basically what you need to do, is you need to isolate your supply from your return so you're guaranteed to force water out through the comfort loop and back through the boiler. Nice one.
Okay, here we're looking at Sir Pumps-A-Lot, and I'd like to quickly go over how the thing works. So basically we've got a reservoir down at the bottom. You have to put on the foot valve so that it holds the water in, and there is an extension for the return water. So basically the components of the system are the foot valve, and that's an inlet that comes into the pump. This is where we're building up the pump pressure. We're sending water out through this cross T, and one branch of the cross T goes out, and that's for geopurging on the left. So that's something that you guys may not get into. But on the other side here, the branch comes off and we go into a bypass that goes right back to the reservoir. That's a bypass valve, the orange handle. And then it comes up and goes into a T where we've got our pressure gauge that'll indicate what pressure we're running at as we're flushing the system. And then we've got an isolation valve for the supply line that's going to go out to the heating system on the supply side. That's the components of the pressure side. Now the return line, it's going to come back from the boiler again. And the return line comes in and it goes into this T here. So there's the ball valve to isolate. This is the return line. It comes in and it goes into another T. Now this branch on the bottom of the T, this one that goes off, again, that's for the geo. These big blue lines in the back are for more higher pressure flushes, bigger systems, higher volume flushes, and geothermal. So basically we've got a 1.5 horsepower pump, which should chase the water out of anything up to about 4 or 5 stories. Looking at it here, so we leave that ball valve closed, and since we are dealing with a hydronic heating system, we are going to use the smaller branches that come off, and this is the return. The return water is going to come back through this line, come down into the T, come in, and go into the filter. Now before you start, you want to make sure that you've opened this up, washed out the filter that's in there so that it's nice and clean, and then put the extension on. The idea of the extension is so that the water doesn't fall so far from the 90 to the reservoir. We want it to fall a little bit through open air so that any air bubbles will be vented off, but if we have too far, as the water splashes, it'll create more air bubbles that'll get sucked up by the foot valve. So that's a basic overview of the system. The other thing we got on here is we have an air vent. So when you're first hooked up and you've got your boiler feed water still turned on, what you're going to do is you're going to open this valve and you're going to open this valve. Water will start to flow through and come in and fill your reservoir up. Once your reservoir is filled to the level where it covers off the bottom of the foot valve, you're going to close this valve, and then what you do is you open the automatic air purger. So when you open the air purger, what's going to happen is it is going to continue to fill. It'll fill up the pump, it'll fill up the line down to the foot valve, it'll fill up the impeller assembly, it'll fill up the cross T, it'll fill up all this branch piping, and what it'll do is it'll vent the air off so that when you go to turn your pump on, you don't have any air. And that's it. So what we're going to talk about here today is setting up the purge cart to properly flush out a hot water heating system. It can be used for a number of different things, but namely the hot water heating system, heat distribution and comfort loop purging is what we use it for. I'm set up here at Twin Lakes, and I'm doing one of the boilers here, which is a really good example because there's lots of them to do here. So the first thing I do is I bring the cart in and I set it up. So I got the reservoir at the bottom. I've installed the foot valve on the pump line. So this is the suction line that comes up to our 1.5 horsepower pump, and the extension on the filter return side. So I've got this all set up. Normally this wouldn't be full of water yet, but I've already filled it. And what we do is we're basically going to follow this line through, and you can see that this is our pressure line. So we've got a gauge on here, and then this is a line that's going to go out to send water out to the system to be flushed. Now the idea is that we're going to send this through in the same direction that the water flows in the system. So if you can see, we've got this line coming through, and since I needed extra hose, I've got my garden hose wound up here. And the idea is that if you do need extra hose, put it on the supply side closer to the pump where your pressure drop is going to be less affected than on the return. We don't want to build up too much excess pressure inside the system. So we're coming off of here, we're going down through the garden hose, and on this boiler, it's not super evident to see, but we've got a, one second, we have got an isolation valve right there that you can see. I got that isolation valve closed off, and we're sending our water in right there. So it comes in, it can't go through the isolation valve, but it can go through the boiler, or it can come up and go through the mixing valve, which is right there. Either way, the water is going to make it out and into the supply side of the supply header without bypassing and ending up back in the return. The return bypass is back there. So you can see I got that isolated, and then there's the return line. Return line comes up through the slab. It's those two pipes there. Comes back and goes to that hose bib right there. So that line I've got coming down, comes around, and it's going into the top of my return on my filter. So before you start pumping here, the first thing you have to do is fill the system, is fill up your reservoir. So what I usually do is I hook up on the return to the return side here. I make sure that my geo valves, which are for the big blue hoses, geo valve is off and off, so we don't get any excess water flowing back. And then what we do is open up the return valve. So what's going to happen is it'll take a minute, but it'll fill the filter canister up. Always check to make sure that the filter is clean before you start. It'll start to fill the canister up, and as soon as it's full, it will fill up the reservoir. So the reservoir is now nicely filled. What we're going to do is we are going to shut off the boiler makeup water, which you can see right there. Stick the flashlight. So there's the boiler makeup water. So now our boiler makeup water is shut off. So basically we're not going to have any more water coming into the system while we're trying to do our job. So What I've done is I've isolated the boiler so that I've got my supply side is where I'm pumping into. It's going to go through the boiler and through the associated piping, and it's going to go out through the zones and come back on the return side and back out of the return line and back to my reservoir. So I am ready to start pumping. So the first thing we want to do is we want to make sure that the pump is completely primed. So I'm tied in there, my valve is open on my supply side. I'm going to open the supply valve, and what I'm going to do is I'm going to open the drain port. Make sure that the boiler water, the makeup water is turned on. I've got water flow through that purge point. When I close this valve, it means that the water is filled up to about this level. Now what I want to do is get the last residual air out of the top. So I'm going to open the air vent until water starts to bubble out. Now I know that my pump is completely full of water and ready to go. So, supply valve open, boiler drain where I'm going in, that's open. Return valve is open, and my return line back to my filter tank is open. So we're ready to pump. So we start the pump. Pump starts going. And what I'm going to do is I'm going to use the bypass to make sure that I'm getting close. Just open it slightly to be able to see that the pump is flowing. Got water flow there, and I've got some water coming back into the film. Now I'm ready to close this valve off and monitor my pressure. So I got a pressure gauge here, which I don't want to see go over 20 psi, usually it runs around 15. And I've also got the pressure gauge on the boiler, which is also matching up and says it is about 15. So that's it. So you let that run for probably about an hour. And while you're at it, you can also open and close your zone valves. You should make sure these are open before you start, or else you won't get any circulation. But you can open and close each individual zone so that you can focus all the pump power on one zone at a time. I usually start with both, and then about 15 minutes in, I'll close one, make sure the other's open, and then I'll switch them. Another 15 minutes, and then at the end, I'll make sure they're both open again and ready to go. A couple other things you can do while you're doing a boiler flush is you can go through and you can do some things on your inspection checklist. Namely, the expansion tank, you can check it while you're doing this. Your automatic air vents, you can check. Another thing you can do too is exercise mixing valves. For example, this mixing valve is pretty seized up. And there we go. I've actually unseized it because that force of that water is going to help do that. Little exercise on the mixing valves, ball valves, all of these things makes a big difference. Just make sure you put them back where they were. What I'd like to do now is show you how to do an addition of F1 boiler protector. Addition of F1, F3, or F5 is all pretty much the same, other than you need to know what chemical does what. So for a system like this, for example, I have no zones upstairs, so it's really quite easy to do. What I'm going to do is I am going to use the boiler relief, and I am going to drain the top half of the boiler system so that I've got some room to accept the volume and no pressure in the system. Room to accept the volume of the canister that I'm about to add. I'm going to remove that air vent at the top, right there, and I am going to inject the solution. Another thing you'll find is when you're opening the can of F1, it's got a funny little pop top, and then it's got a goofy little adapter like this. This goes on the end of here, it screws on and gets tight, and then this end here has got a threaded adapter in case you want to put this into a nipple. The other thing it comes with is it comes with a point. I usually swap it out, use the point, because I'm going to put it in where the air vent came out.